मी जर रविवारी सुट्टी द्यावी आणि मंगळवारी शाळा घ्यायला पण ते मूड दाखवतं ना रविवारी मग काय वाटत नाही रविवार काय सुट्टीला काय रविवार सारखं झाले.
Okay. So my voice is audible?
Yes, sir.
So in the morning, we have seen about the statement of D'Alembert's principle. Now we will see how we can include the inertia force while solving the numericals. So first of all, now we will start with the numerical. So write down the problem. An elevator cage of mine shaft weighing 8 kilonewton when empty. Is lifted or lowered by the means of wire rope. Full stop. Once a man having weight 600 Newton entered in it and lowered with  uniform acceleration such that when a distance of 187.5 meters is covered such that the velocity of cage was 25 meters per second. Full stop. Determine the tension in the rope and force exerted by the man on the floor of cage. Okay. Now, what is the problem we will see? An elevator cage. Elevator cage means lift. An elevator cage of mine shaft. Okay. In a mine shaft, we use that elevator cage. पिंजऱ्यासारखी जाळी असते त्यातनं लोक वर खाली करतात. So an elevator cage in a of a mine shaft weighing 8 kilonewton. So weight of that lift, that elevator cage is 8 kilonewton when empty, when it is empty, and is lifted and lowered by the means of wire rope. So it is lifted or lowered by the means of string is there, rope is there. Once a man having weight 600 Newton entered in it and lowered with uniform acceleration such that when a distance of 187.5 meter is covered, the velocity of cage was 25 meter per second. So the weight of man is 600 and he is going down, and he is going down with a velocity of 25 meter per second, and the distance covered is 187.5. Determine the tension in the rope. Let us say that T is the tension in the rope. So that we need to find out. And force exerted by the man on the floor. So the normal reaction given by the floor to the man, that we need to calculate. Okay. So first of all, I will draw the diagram. Suppose now this is the lift. This is the elevator cage. Okay. So in this elevator cage, its weight is 8 kilonewton and the weight of man is 600 Newton. So when this man is entered into the cage, what will be the total weight? 8,600. So that total weight we will show. I have already told you, we always show the weight vertically downwards and it must act through the centroid. So here this is 8,600 Newton. Okay. Now the man is lowered. म्हणजे तो कुठे चाललाय, खाली चाललाय. So the direction of motion we will show. So this is the direction of the motion. The lift is moving down. This is the direction of the motion and it is lowered by the means of rope. So here it is string. Tension in the string is T. For tension, arrow must be away from the joint. Just 1 minute. See, I will repeat as it was new. See, this is the inertia force MA. So if the motion is downward, the inertia force is always opposite to the direction of the motion. So always frictional force and inertia force both are always in the opposite direction of the motion. As motion is downward, the lift is lowered by the man. So the inertia force will be upward. Okay. So to calculate this inertia force, we know the mass now. The value of m is known to us. Okay, because weight is known to us. From weight we can calculate m, but acceleration is not known. So to calculate acceleration, we will use this data. Okay, this data. So initially the lift was at the rest and then the man started to lower it down. Okay, so here I will write initial velocity is 0 meter per second. Okay, so v is 25 meter per second when your distance covered is 187.5. Okay, so now if I use the equation v square is equal to u square plus 2as, then v square is 25 square, u square is 0, plus 2a into s is 187.5. So therefore, if you solve this, you will get the value of a, and it is 1.66 meter per second square. Check the value. Correct? Now, once you know A, acceleration, okay, then calculate this inertia force. So, inertia force is equal to MA, which is equal to M is what? Mass is equal to weight is equal to mg. W is equal to mg is the formula. बरोबर है? W is equal to m into g. Mass into acceleration due to gravity. So therefore, m is equal to what? It is W upon g. झाला ना formula? So here I can write mass is equal to nothing but W by g into A. So which is equal to W is 18600 divided by G is 9.81 into A is 1.66. So therefore inertia force MA is equal to 1455.24. This is the inertia force. Okay. Inertia force. Now this diagram, this is free body diagram of cage. This is free body diagram of elevator cage. ओके. हवेमध्ये फ्रिक्शन नसणार आहे, त्यामुळे तो फ्रिक्शनल फोर्स आलेला नाहीये. सो हियर टेंशन इन द स्ट्रिंग, then here it is the weight, and this is the inertia force. Okay. So now consider this diagram. Okay. Now consider the free body diagram of cage. Consider free body diagram of cage. Okay. Applying summation Fy equal to 0. So now if you apply summation Fy equal to 0, what you will get? T, it is moving upward, plus minus 8600 moving downward, plus Ma. So write all this. So it is T minus 8600 plus Ma is equal to 0. So T plus, what is the value of inertia force? Ma 1455.24. Right? Inertia force Ma minus 8600 is equal to 0. Therefore, T is equal to 7144.76 Newton. Alaka?
Yes, sir.
Okay. So now the first part of the numerical is over. Okay, determine the tension. Okay, this part is over. Determine the tension in the rope. Now what is the second part? The second part is force exerted by the man on the floor of the cage. Now the man is inside the cage, inside the lift. So what force he must exerted on the floor of the lift? So whatever force he will exert on the floor, he will get equal and opposite reaction from the floor. So whatever is the value of the reaction of the floor, that much force is exerted by that man on the floor. Okay. So here now what I will do, I will draw the free body diagram of man. So free body diagram of man. So now this is a lift floor, cage floor, and here the man is standing. Okay. So the normal reaction he will get, it is like this. This is the normal reaction. Okay. This is the normal reaction R. And the weight is from here. I will show the weight. This is the weight. This is the weight of the person, and this weight is 600 Newton. Okay. And the motion, obviously it is moving down. It is given in the problem. So this is the direction of the motion. So the inertia force will be in opposite direction. So this is the direction of the inertia force. This is MA. Okay. So now we will calculate the inertia force. Here you can call this as free body diagram of man. So inertia force is equal to MA. Now we know the weight, so it is W by G into A, so which is equal to MA, which is equal to W is 600 divided by 9.81 into A is the acceleration. What was the value? 1.66. So MA is equal to 101.52 Newton. This is the inertia force. Now again, apply summation Fy equal to 0. If you apply summation Fy equal to 0, it is minus 600 plus R plus 101.52 is equal to 0. Therefore, R is equal to, it is 498.48 Newton. This is the reaction. So this is the pressure exerted by the man on the floor of elevator. Is there any doubt in this numerical? काय डाऊट याच्यात काहीच नाही समजलं इकडं ऑनलाइन इज देयर एनी डाऊट
No, sir.
प्रॉब्लेम मध्ये काय अडचण आहे का या कुठला पार्ट समजला नाही असं यस नो काय पुढे जायचं मग
Yes, sir.
ओके टेक द नेक्स्ट प्रॉब्लेम बॉडी weighing मॅडम लेक्चर मध्ये नंतर बोलतो लेक्चर चालू आहे नंतर बोलतो 6 वाजता हा फोन करतो तुम्हाला लेक्चर मध्ये एमजी देशमुख सर आहेत आता प्रोजेक्ट कोऑर्डिनेटर मी नाही एमजी देशमुख सर आहे डॉक्टर एमजी देशमुख मी नाही आता प्रोजेक्ट कोऑर्डिनेटर So, a body weighing 1200 Newton rest on a rough plane inclined at an angle of 12 degree to the 12 degree to the horizontal. Full stop. It is pulled up. It is pulled up by the plane by using light flexible rope running parallel to the plane. Running parallel to the plane and passing over frictionless pulley. Passing over frictionless pulley at the top of the plane. At the top of the plane, as shown in figure. As shown in figure. The portion of the rope the rope beyond the pulley hangs vertically and carries the weight of 800 Newton at its end, comma, if the coefficient of friction for plane and body is 0.2, then find number 1, tension in the rope, number 2, acceleration with which body is moving, and third, the distance moved by the body in 3 seconds after starting from rest. After starting from rest. Okay, so this is the given problem. So we will read the problem. A body weighing 1200 Newton rests on a rough plane inclined at an angle of 12 degree with the horizontal. It is pulled up by the plane. So it is pulled up by using a light flexible rope parallel to the plane and passing over the frictionless pulley at the top of the plane. The portion of the rope beyond the pulley hangs vertically and carries a weight of 800 Newton at its end. The coefficient of friction is 0.2. Find the tension, then acceleration, and the distance moved in 3 seconds. These things we need to calculate. So the diagram is given. So we will draw the diagram first. Here is the block. Yeah. The weight of this block is 1200 Newton. And this is inclined at an angle of 12 degree. Now a string is passed, it is attached to the string. This string is passed over the pulley. This is the pulley. And now this string is passed over the pulley. Okay. And what is the weight attached over here? Here is a weight attached. This weight is of 800 Newton. And the direction of motion, it is move up the plane. So up the plane means this is the direction of motion. Direction of motion is very important. This is the direction of the motion. So this is the given problem. So we need to solve this problem. Okay. Tension in the rope. So let us say that T is the tension in the rope. So same rope is passed. So the tension in the rope will be same. From here it will be T like this, and from here also it will be T like this. Arrow must be away from the body. Okay. So now first of all we will consider the free body diagram of this 1200 Newton block. Then we will consider the free body diagram of this 800 Newton block. So the free body diagram of this 1200 Newton block, if I draw, so now this is the inclined plane. This angle is 12 degree. Here it is the box. That is the body. This is the center of gravity. Now the load is acting towards the ground. Load is always act vertically downwards. This is 1200 Newton. Okay. So now this is the direction of the motion. This is the direction of the motion. Now this inclined axis is our x-axis and perpendicular to this is our y-axis. Okay, these types of problems we have already solved. Okay, so now this is our x-axis. This axis is y-axis, reference x and reference y, because it is on the inclined plane. Body is on the inclined plane. Now, if I resolve this, then I will get one component towards this direction. The other component, it is in this direction. Okay. So if this angle is 30 degree, 12 degree, then this angle is also 12 degree. Angle between the lines is angle between their tangents, normals. This is the horizontal line. This vertical line is perpendicular to this horizontal line. And this component line is perpendicular to this surface. So if the angle between these two is 12, then the angle between these two must be 12 degree. Now draw the normal reaction. So the normal reaction will be like this. This is the normal reaction R. We would call this normal reaction as R. Then the frictional force. Here it is the frictional force, which is parallel to the plane. This is F. F is the frictional force. Now the tension in the string. So here this is T. This is T, tension in the string. Okay. Now the MA, frictional, here the inertia force will be opposite to the direction of the motion. So what is the direction of inertia force? Here if you show the inertia force, this is the direction. This is the direction of the inertia force, MA. So after this free body diagram, now if I apply some, if I resolve this, then this will become one two zero zero cos of 12. This is 1200 sine of 20. Now consider this y-axis as your reference axis and this, consider the forces parallel to this y-axis. So here it is R minus 1200 cos of 12. Nothing is there, only two forces is equal to 0. Therefore, R is equal to, what is the answer? Is it right?
Yes, sir.
Yes, sir. Yes, sir.
So this is the value of R, normal reaction. Now, once we know this R normal reaction, we can calculate frictional force. So F is equal to mu into R. So what is the value of mu? It is given 0.2 into R, 1173.77. It is 234.75 Newton. That is the frictional force. Okay. Now apply summation. Here it is summation Fy equal to 0. We have already applied. Now summation Fx equal to 0. So summation Fx equal to 0. So this t is moving towards right side. So plus minus 1200 sine of 12 minus frictional force 235.75 minus parallel ma. Inertia force is remaining. Okay. So M is 1200 divided by 9.81. Okay. M into A as it is. So reshuffle this, you will get one equation. And the equation will be T minus 122.32A is equal to 484.24. Please check the equation. Okay. Now consider the free body diagram of this 800 Newton block. Now the 800 Newton block I will draw. Here it is the 800 Newton block. The center of the block is somewhere here. This is the load 800 Newton. Here it is normal reaction R. Direction of motion. Now direction of motion is the downward direction. This is the direction of the motion. Therefore, the inertia force will act opposite to the direction of motion. This is MA. Okay. So now here, if you apply summation Fy equal to 0, what you will get? The correct tension, correct. Here it is tension. Because it is connected, see, this is connected by a single string. Whatever tension is there here, it's the same tension will be developed throughout the string here also. So it is attached by tension. So here it must be tension. So now, if I apply summation Fy equal to 0, then it is plus T plus Ma minus 800 is equal to 0. Therefore, T plus M is W by G. So W is 800 divided by G is 9.81 into A. Acceleration किती काढलं होतं आपण? काढायचं आहे. So it is acceleration as it is, which is equal to 800. त्या साईडला पाठवा 800. So what is this? T plus 81.54A is equal to 800. This is our equation number 2. Now solve these two equations, you will get the value of T and A. So these are the answers. Please check it. Correct? Any doubt? No, it is not still solved. Now three types. So tension in the rope, we have found out what is the tension in the rope. See, we have calculated this. Now acceleration of the body is also calculated. Here you can see tension and acceleration. Now third thing is remaining. The distance moved by the body in 3 seconds. So time is given after starting from rest. So initial velocity is 0. Okay. So we need to calculate the distance. How do we calculate that? So we will use S is equal to ut plus half at square. So therefore, S is equal to, this term is 0 because it is starting from rest, half into A 1.54 into time is 3 seconds. After 3 seconds, they told us. What is the displacement? .93 meters. Correct?
Yes, sir.
So 6.93. Any doubt? इकडं काय डाऊटच नसतं कधी. ते सगळं समजते का काहीच समजत नाही, काय प्रॉब्लेम? सगळ्यांना विचारतो मी. समजते का तुम्हाला सगळ्यांना? यस नो काय समजते तिकडं? उभी समोर उभी हो 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 हो. समजते का उभी विचारायला लागलो म्हणून हो म्हणायचं? इकडं ऑनलाईन समजले काय घेतलेला प्रॉब्लेम?
Yes, sir.
Yes, sir.
Okay, good. चलो next problem then. Two weights 800 Newton and 200 Newton are connected by a rope and they move along rough horizontal plane. Under the action of 400 Newton force, 400 Newton force applied to the 800 Newton weight. As shown in figure. The coefficient of friction between sliding surface and the plane, sliding surfaces and the plane is 0.3. Using D'Alembert's principle, determine acceleration and tension in group. Okay. The diagram is given to you. So I will draw the diagram here. Okay, so the given diagram is, this is the surface. Then two blocks are there, 200 Newton, and this is a block of 800 Newton. These two blocks are connected to each other by a rope. The rope. Okay. And then 400 Newton force is applied over here on this block. This is 400 Newton force. Now these are the centroids of the block. So from the centroid, the weight of the block is acting. What is the weight? This is 200 Newton. This is 800 Newton. Now we will get two normal reactions. Normal reaction here. Here also we will get the normal reaction. Let us say that this is R1, this is R2. So the direction of motion is in the direction of the force, applied force. So this is the direction of the motion. This is the direction of the motion. So frictional forces will be opposite to the direction of the motion. So this is the frictional force for first block. This is the frictional force for second block. So let us say that this is F1, this is F2. And the inertia force obviously opposite to the direction of the motion. So the inertia force will be in this way here. This is inertia force. So here there is no need to show the inertia force. This is only the given problem. Now in your free body diagram, you should show the inertia force and everything. Okay. So this is the given diagram and numerical is there. Read the numerical and try to solve it. Okay, so using D'Alembert's principle, determine acceleration and tension in the rope. So draw free body diagram of each block. So now if we draw the free body diagram of first block of 200 Newton block, then how will be the free body diagram? This is the surface. On this surface the block is resting. This is the centroid. Weight of block 200 Newton. Here it is the frictional force F1, normal reaction, it is R1, this is the tension, here, this is T, then this is the direction of motion, this is the direction of motion. So your inertia force will be the opposite direction of the motion. So here will be the inertia force. This is the direction of inertia force. This is ME. Okay. Now if I apply summation Fy equal to 0, summation Fy equal to 0, then R1 minus 200 is equal to 0. Therefore, R1 is equal to 200 meters. Once we know the R1, we can calculate F1 because the value of mu is also given, mu is 0.3. So now F1, F is equal to what? Mu into R. So F1 is equal to mu into R1. So mu is 0.3 into R1 is 200. So what is F1? It is 60 Newton. Okay. It is 60 Newton, value of F1. Now calculate the value of inertia force MA. So MA directly we will calculate in the problem. So here, if I apply summation Fx equal to 0 now, summation Fx equal to 0, then what do I will get? So T minus F1 is 60 minus MA is equal to 0. So T minus 60 minus M is W by G. So 200 divided by 9.81 into A. So T minus A कितने है? 20.38 A is equal to 60. This is equation number 1. Similarly, draw the free body diagram of second block also, 800 Newton block also. Now the free body diagram. So 800 Newton. Again, the same things will be there. Here it is the frictional force. Now this is F2, second block. Normal reaction, this is R2. Here is the force, 400 Newton. Then again, here it is tension in the string T. Then this is direction of motion. Then inertia force. So this is the inertia force opposite to the direction of the motion, MP. Now if I apply summation Fy equal to 0, then it will be R2 minus 800 is equal to 0. Therefore, R2 is equal to 800 Newton. And F2 is equal to mu into R2, which is equal to 0.3, because here also mu is given as 0.3 into 800. So how much it is? 240 Newton. Now apply summation Fx equal to 0. So summation Fx equal to 400 minus T minus F2. F2's value is 240. That minus MA. M is 800 divided by 9.81 into A. Anything else which is remain? No, which is equal to 0. Right? So send these two terms to that side. So it will be T plus this term. How much it is? 81.5 A, which is equal to 400 minus 240. How much it is? 160. This is equation number 2. So solve the equation 1 and 2 on the calculator. Ax plus by plus c. शिकवलंय तुम्हाला कसं सॉल्व करायचं ते. सॉल्व करा आणि आन्सर सांगा.
इक्वेशन 1 एकदा दाखवा.
Equation 1.
Okay, sir.
What is the value of it? 0.981 meter per
equal to
second.
79.99.
It is 79.99 म्हणजे 80 ना?
Yes.
80. Okay. So have you understood this problem? असले problem समजले का? These are the problems of connected bodies. In your this unit, there is one bit, the numericals on connected bodies. So by using the D'Alembert's principle, in this way we can solve the numericals of connected bodies. Now here you can see these two blocks which kept on the horizontal plane. These two, these are nothing but the connected bodies. These are connected to this rope. So we have solved the problem. Previous also. Now this block. So this is also the problem of connected bodies, but it is on inclined plane. Okay, म्हणजे सगळ्या टाइपचे प्रॉब्लेम आपण घ्यायला लागले. This is of the lift problem. Now the next problem, next is of the pulley. We'll take one problem of pulley. हाँ? कळालं? बरं, ठीक आहे. कसली टेस्ट आहे? युनिट टेस्ट आहे.
तर युनिट टेस्ट 6 वाजता.
इंजिनिअरिंग मेकॅनिक्स. ठीक आहे. Okay. So today we will stop over here. In the next lecture we will cover the remaining part. पुढच्या लेक्चरला हे युनिट संपतं.